So with implicit differentiation, let me explain to you what implicit means. Okay, first of all, you're normally given these types of equations and where it's y equals, right? Most of the time in math class, you have y equals. We haven't given that a name before, but that's called explicit. Okay, it means y by itself. And even when y is not by itself, a lot of times we would get y by itself. Okay? But we also have these equations like this, where y is not by itself. And in fact, it's very difficult, if not impossible, to get y by itself. This is called implicit. So if you're like, why are we calling this implicit? It just means y is not by itself. Okay? The only time that you've really seen a lot of this before this class is when you did conic sections, like hyperbolas and ellipses and all that. What we're doing isn't really going to look like that, but those were also implicit equations. Okay? So in order to take the derivative of an implicit equation, we're going to use implicit differentiation, and that's actually the title of the notes. By the way, it's October 2nd, right? Not October 1st. Okay, when finding dy over dx implicitly, you must realize that the differentiation is taking place with respect to x. Now this doesn't mean much to you, but let me tell you, we have already been doing this. Every time we take the derivative, it's with respect to x, because our functions have been of x. Okay? But when you differentiate terms only involving x, you just do the usual thing, okay? But when you differentiate terms involving y, you have to apply the chain rule. So let me explain to you in this first example what that even really means, okay? So we're going to find dy over dx. By the way, dy over dx is the exact same thing as y prime. We're not going to use y prime notation here for a particular reason that I'll explain once we're done with the problem. You'll see why. All right, so I'm going to differentiate with respect to x. If I write d over dx in parentheses, what this notation means is that I'm going to take the derivative of this. Okay, so what is the derivative of y cubed? What do you think it is? All right, so 3y squared. Now the only thing is, we saw up here, just a couple of lines up, it says, when you differentiate terms involving only x, you just do usual, but when you differentiate terms involving y, you have to apply the chain rule. So think of this y cubed like an M&M, where the cubed part is the shell and the y is the chocolate. Once you differentiate the shell, then you have to differentiate the chocolate. So what we have to write after this is times dy over dx. And later on, this is what we're going to get by itself. So let me explain this again, okay? Whenever you take the derivative of a y term, when we're doing implicit differentiation, you're going to do the derivative, power rule or whatever rule you need to apply. But then you have to, y is a function of x. So you have to take the derivative of y with respect to x. The way most of you are going to remember this is anytime you derive a y term, you're just going to write dy over dx after it. You're probably not going to think through these steps every single time. So let me keep going, and I want you to see when I do this and when I don't. So x cubed, that's just an x term. So the derivative of that would just be 3x squared. And I would not write dy over dx next to it. You're only going to write dy over dx next to terms that you've differentiated that have involved y. Okay, so negative y squared or minus y squared, what would the derivative of that be? Yeah, minus 2y, and because it's a y term, that's right, you're going to write dy over dx. And you can write the times, or you don't, or times is implied, either way. Right, so what's the derivative of minus 5y? Minus 5, and because it's a y term, dy over dx. Even though we took the derivative and the y went away, it was still a y term that we derived. Okay, now we have to differentiate minus x squared. So we write minus 2x, and you don't have to write anything after that. What's the derivative of negative 4? 0. So let me just say one more time what we did here, okay? Every time we took the derivative of a y term, we ended up writing dy over dx after that thing's derivative. And that's an application of the chain rule, because y itself is a function, so it's a function of a function. Okay, so that's how you take the derivative. Now our answer has to be in dy over dx. So down here at the bottom, I'm going to have dy over dx equals. So I got to get that by itself. Well, what I'm going to do is I am going to kind of box in, and you did this when you were first learning algebra, how to combine like terms. So here are all the three of the dy over dx terms. Okay? Remember, you're trying to get dy over dx by itself. So keep these things on the left-hand side. The other two, excuse me, the other two, you're going to move those over to the right. So this is going to be 3y squared dy over dx minus 2y dy over dx minus 5 dy over dx. So I just rewrote those three terms that I boxed. The other two things I need to move over to the right side. Well, you do that by adding or subtracting. Okay? So like here, I would add this 2x over to the other side, and that would cancel there, and that would give me a 2x on the right side. What would happen to this positive 3x squared? I would subtract it, and it would become minus 3x squared. Okay, so I'm one step closer to getting the dy over dx by itself. I still have it in three places, though. How can I condense these three dy over dx's into just one? What could I do algebraically? Factor, exactly. So if you're like, I couldn't have thought of that, that's okay. Now you know. If you have three dy over dx's, then you can factor out dy over dx, and what's left in parentheses are these three items. So 3y squared minus 2y minus 5. And the right side, nothing happened to that. Okay, so remember our final goal is to get dy over dx by itself. So what's the last thing we need to do? I'm going to divide, okay? So I already had, I'm going to divide, and I'm going to divide. So I end up getting 2x minus 3x squared divided by 3y squared minus 2y minus 5. Okay, that gets rid of that term. So it's a lot of writing, okay? But if you can remember the steps, you're in good shape. So let's go back over the steps again before we try another example. So the first thing that we do is we differentiate, okay, I'm going to abbreviate here, with respect to x, which means dy over dx goes next to the y terms. That's really what happened. We took the derivative, and anytime we took the derivative of a y term, we wrote dy over dx next to it. All right, what was the second thing what we did? Right here in blue. So we got the dy over dx terms, we kept them on the left. All right, because if I'm going to factor them, I only want dy over dx on the left. So dy over dx on the left. Okay, and then we had several dy over dx's, but then we got to one by doing what? We factored. So the third step here would be to factor the dy over dx out. And then the last step, this is the easy step. Once you get here, you should know, just divide over that term. Okay, I know it seems like a lot right now. Your brain could be like overwhelmed, flight, but just stick with it, okay? Just like anything else, first time you do this, it's kind of difficult, kind of seems weird, but you can get better at it. By the way, before I move on to the second example, I do want to just point out that what we found here is the slope function. If I knew a particular x and y, like on this graph, I could plug it in here, and then that would tell me the slope at that point, just like how derivative has meant this whole time. All right? So let's look at the second example here. All right? So first thing is, we differentiate with respect to x. So this is where we go d over dx to both sides. Now, what's interesting is, see this 2x to the 6, y to the 9th? That's a product. So how are we going to differentiate it? Product rule, right? I know, right? Just when you thought we got rid of that one. All right, so it's not too bad, though. So the derivative of 2x to the 6th, that's just 12x to the 5th, right? And then I'm going to multiply that by just y to the 9th. Plus. Okay, here's the second part of product rule. Then you just write 2x to the 6th times the derivative of y to the 9th would be 9y to the 8th. It's a y term, so I'm going to go times dy over dx. Okay, so everything that I've written has just been the derivative right here. I had to use product rule. Any questions?
Why wouldn't you write dy over dx after the first one?
So, am I just writing y to the 9th, or am I differentiating it? I'm just writing it, right? So, when you take derivative of y, then you got to write the dy over dx. But if you're just writing it, just write it. It's a really good question. Okay, let's look at the next thing. What's the derivative of plus 3x? Y'all look tired. Plus 3, right? Just regular old plus 3. Minus y cubed, that derivative would be minus 3y squared dy over dx. Again, I'm doing the dy over dx because I took the derivative of a y term. All right, equals 0, because the derivative of a number is 0. This right here, believe it or not, you guys are going to get you're going to get really good at this calculus, because we're going to do it a lot. But what a lot of students tend to forget is that the derivative of a number is 0, and they want to like rewrite the number here. Okay, remember you're taking derivative though. All right, so let's, whoops, not that one, right? All right, so here we go. That term and that term, those are my only dy over dx terms. So I need y'all to pay attention to this, because this has been freaking people out all day. Are y'all okay if I just go ahead and say that 2 times 9 is 18? So that's 18, right? Somebody's going to ask me in a minute, how did you get 18? I just multiplied 2 times 9.
Okay.
You don't have to do it, but I'm going to go ahead and do it because we kind of do need to learn how to simplify a little bit for multiple choice problems. Okay, then you have x to the 6th, y to the 8th, dy over dx, and then I have minus 3 y squared dy over dx. What gets moved over? The other things. And so I'm going to really encourage you guys to box and do what I'm doing. And if it even helps you to kind of color code your notes right now or your homework, doing each step in a different color, do that. Do whatever you need to do, okay? So I'm going to subtract that 12, x to the 5th, y to the 9th, and I'm going to subtract the 3. Okay, both of these terms, I'm just subtracting them over. Okay, my next step is to factor. So I am going to write dy over dx, and I'm going to factor 18 x to the 6, y to the 8, minus 3y squared. Oh, you're fine. So I took the derivative, I kept the dy over dx terms on the left, and then I factored out the dy over dx.
Okay, why did we multiply that 2 times?
If you didn't, you would be fine.
Okay.
You would have been totally fine. I just took that little simplifying and I went ahead and did it. These problems tend to be more multiple choice than not, in which case you have to just know how to simplify. But, and so I wanted to just bring it up on this problem. But you didn't have to. You could have left it as 2x to the 6 times 9y to the 8. That would have been okay. Okay, so I'm kind of running out of room here, so I'm going to write my answer here. dy over dx equals negative 12 x to the 5th, y to the 9th, minus 3, over, and then this is the term I'm dividing, 18 x to the 6, y to the 8th, minus 3y squared. That is your derivative. You definitely do not need to factor or try. If there's like an obvious thing to simplify, go ahead and do that, or don't do it, whatever. But you don't need, I can't cancel like these out. I can't even do that because this minus 3 binds that together. The only thing I could do is try to factor something out. And if it factored out from the top and the bottom, but that's really never going to happen. They're always going to be messier than that. Like this one. I mean, it won't be messier than this, but it doesn't simplify down nicely. Okay. So the next thing says, okay, find the slope at of the curve at x equals 0, y equals negative 2. So this right here, you did the hard part. This next part's not hard. You've already done this. To evaluate the slope, use the derivative. Now, we're going to start writing this down, and you might just get a little bit of panicky right about the time you start writing negative 2 to the 9th power. However, you do not have to do negative 2 to the 9th power. Why? Why do you get out of it? Well, it's not just that. Look at this. Look at this whole term. If you multiply by 0, I don't care how this is, you are multiplying all of these numbers together right here. So that whole thing is 0. That's why we chose this point. Okay? I would never have you do this problem where you have to start doing all crazy numbers. Okay? So look for easy ways to crunch the numbers. 18 times 0 to the 6, I don't even care what's right here. If you multiply by 0, it's gone. So what you're left with is negative 3 over 12, negative 12, which simplifies to positive 1/4. Okay? So what this means is, at the point 0, negative 2, the slope of this line is positive 1/4. Okay? Okay, I know this is weird, but any questions? Okay, let's look at the next page. Okay, number 3. So you guys tell me, what's our first step? I mean, look on the first page if you want. Derive. D over dx of both sides. So what's the derivative of cosine of 2y? Keep going, you're good. negative sine 2y times 2 dy over dx. That's pretty close. Okay, so I see some puzzle faces, so let me explain. This is equals 1, correct. So derivative of cosine is negative sine. By now that needs to be like, you need to tattoo that on your hand if you can't remember that. Just kidding, obviously. Keep the 2y alone. Then do times 2 because the derivative of 2y is 2. This is just an M&M problem. This is chain rule, basic chain rule. Because I took the derivative of 2y, I took the derivative of a y term, I have to write dy over dx. Now, you want to know the best thing about this problem? Is you totally don't have to worry about getting the dy over dx on the left, because there's only one term, and it's already on the left. Do you need to try to factor? No, because it's only one term. You can go straight to dividing, because there's only one term. Okay, we couldn't have done this on the other problems. All right, I know it's weird. I told y'all when we started, this is a weird thing. All right, dy over dx equals. Now, let me just say for the record, this right here is an okay answer, especially on free response. You should just leave your answer just like that. However, let's say this is a multiple choice. None of the answers are going to look like this. They're going to do a simplifying step. So let me show you how you can think about it. So negative 1/2 is right. We got the negative, we got the 1 over 2. But what is 1 over sine? The same as. What's the other trig value? Close. Cosecant. Remember the reciprocals? The reciprocal of sine is cosecant. That's going to be the answer choice that they have. Now, if you didn't think to do that, that's okay, because you'd see your answer choices and go, oh, they did something weird here, I need to figure it out. Okay? It's not like you just got to be clever enough to figure it out. All right. Good news is for today, we're not going to do number 4. All right? We're going to go straight to number 5. Okay. Last problem. Now hang with me. Okay, what is this y? What is that? Double prime. And another way to write this would be d squared y over dx squared. Any of you wonder why the squared's in a different place on top and bottom? You ever wonder that? Okay, I'm going to tell you on another day. Not today, but just know that. If you haven't thought about it, think about it. All right, so to do second derivative, we start just by taking the derivative. So I want you to do this one on your own. Okay, just the first, and then we'll do the second one together. You can do it. Just try it. Alright, so on this, you should have gotten 2x plus 2y dy over dx. And as I walked around, most of you were good to that step. Okay, what'd you do next?
2y. Subtract 2x to get 2y.
So we subtracted 2x to the other side, and then what? Then you just divided by 2y, right? Now, is there any other, like, basic simplifying step? Yeah, you could cross the 2's off, so. By the way, do any of you know what shape that is? It is a circle. And this circle, all equations of circles are x squared plus y squared equals r squared. Did the 25 even play into this? No. So every circle that ever existed, this is the derivative. Every circle. This is the derivative. All right, that's not something you have to memorize, but you could, I guess.
Wait, even if there's like a coefficient?
What, you could divide that out, and then that would change this number, and then it would still go away. So yes, every circle. Not the other ones, but just circles. Okay, so here's the second derivative part. We're going to do this part together. We're going to take the derivative of both sides again. That's going to cause this to be d squared y over dx squared. Any of you kind of see why it's d squared y over dx squared now? Maybe? All right. So we got to use quotient rule. Derivative of the numerator is -1. Then you just write the denominator, minus. Then you just write the numerator. And now we get to derive the denominator, which would be 1 times dy over dx.
Wait, why isn't it d squared y over d squared x squared?
Are you saying this?
Yeah.
This is more notation than anything else. We're going to talk about this another day. Okay? Why the notation is. For right now, just accept it. Sorry, I hate being like that, but we don't have time to go through that right now. Okay, over the denominator squared. Everything's good here except for this. In explaining the second derivative, you can't have a term for the first derivative in there. However, this is a really easy fix. This could be complicated, but it's not. Look right there. Negative x over y, just place it right there. So, -1 y minus negative x, and then negative x over y all over y squared. And sure, this could probably be simplified a little bit, but for today, let's just leave it at this. Okay?
Wait,
Yeah.
why did you